All right, tides. The moon and its gravitational force on Earth actually controls the tides. Now, I say that, but I do want to stress the sun has a larger gravitational force on Earth than the moon. We orbit the sun. We are more attracted to the sun. The moon is attracted to us because we're bigger. The sun is the biggest, so it has more of a gravitational force. You would not believe how many people tell me that the moon has a bigger gravitational force on Earth than the sun. So the sun is definitely a stronger gravitational force to the Earth than the moon. However, the moon does have a gravitational force, right? Anything with mass is gravitationally attracted to anything else with mass. So the moon being as big as it is and the Earth being as big as it is, we are attracted to each other. This attraction actually causes our tides. It creates a tidal bulge. Okay, and why just the tides? Well, because the moon is not big enough. Its gravitational force is not strong enough to move the rock of the Earth or the Earth itself. So when it pulls on us, the only thing it can actually get is the water to move. All right, so the tidal force is actually a force that depends on the moon's gravity to the Earth. And so depending on where the moon is, you get a different tide. High tide, low tide, etc. Now, high tides occur twice a day. And this is not to say that the sun has no effect on the tide. That actually helps out the tide. Okay, so it does have an effect, however, it's just much less because the moon controls the tide. There's two types of tides, spring tides and neap tides. So the spring tides is the top picture. And the top picture, you can see the sun, the moon, and the earth are all in an alignment, right? They're all in a straight line. And this is called a spring tide. It makes high tides taller. Okay. Now, the neap tide happens when the sun, the earth, and the moon are all at 90 degrees from each other. Right? So the sun, the moon, and sorry, not the sun, the earth, the moon are either up and down, and the sun is across. Okay, so 90 degrees. And this actually pulls, the sun's pulling one way, the moon's pulling the other way, so they're pulling against each other. So the high tide isn't going to be quite as high. Right? So when they're pulling all in a straight line, the sun and the moon are pulling together, so your high tide is higher, and your tides aren't as noticeable when you're in a neap tide. So this is kind of interesting. Because of the tides, there's actually a drag on the Earth, and it's causing our rotation to slow down. So it's not exactly noticeable, but the Earth is slowing at 2 milliseconds every 100 years. Again, even if you live to be 200, you're not going to notice it. What's also interesting is that the moon is pulling away from the Earth 4 centimeters every 100 years. So again, if you're going to live to be 200, you're not going to notice it. Now, this will continue, the moon pulling away, the Earth slowing down, until the same side of the Earth is pointing to the moon at all times. So one side will be pointing towards the sun, the other side will be pointing towards the moon. Nothing's going to change. And if you're living on the side that's facing the moon, all you get to see is the moon. If you're living on the side that's facing the sun, all you're going to get to see is the sun. Kind of a bummer. Now, this has kind of happened with the moon. The moon is what we call tidally locked. The moon always has the same face towards us. So we always see the same side of the moon, no matter what. We can't see the other side, the far side of the moon as we call it, unless you literally get into space and go around to the other side of the moon.